Hello everyone, here we have distribution of sample mean. Here on this part we have sampling distribution of statistic is probability distribution for all possible values, and that is when we have the sample size of n. Okay, so here is sample size of n, and on this part sampling distribution of the sample mean is x bar. So here is mean is x bar, and so the sampling, the distribution of a sample mean x bar is the probability distribution of all possible values. And for value we have, all the values we have x, and here again we have sample size of n from a population. And for population our mean is, okay, so this mean is for population and standard deviation is this part. So I'm memorizing what we had on top. I'm writing here. So for population, mean is and we have for standard deviation that is equal to the sigma. Okay, and then I wanna cover this part, and then we'll come back to this table. Okay, so the mean and standard deviation of the sampling distribution of x bar. This is based on what we can choose from our population. Okay, I'm writing for that point here. So for sampling distribution of x bar, for this part, mean based on x bar is equal to population mean and standard deviation for this x bar is equal to population standard deviation divided by square root of what sample size is. Okay, now here on this part, we have this table, and here is sample, the first sample and second sample of 216 samples we have, and this is x bar. How we can get that number? Adding all the data on the first row, 90 plus 40, 74 plus 95 plus 88 plus 91 plus 91 plus 102 plus 91 plus 96. Adding all these numbers divided by how many we have is 9 is equal to 90.9. So x bar is equal to sum of all that data. So sum of, so we have C1 up to C9. Then divide by how many we have. In total is 9. That is equal to 90.9. So same thing for each row. Okay, now let's work on an example on this board. This part is very close to what we covered on the previous chapter. The only difference here we use x bar instead of x. So the shape of sampling distribution of x bar, if x is normal, here we have if a random variable x is normally distributed. So if that is normally distributed, the distribution of sample mean as x bar is normally distributed. Now example number 1, a simple random sample of size n, so here we have n, is obtained. So that one was from what the population is here on this part. And this population is normally distributed. This is important. And for population mean is 80 and our standard deviation is 14. Okay, let's see. Okay, so for population, here mean is 80 and standard deviation is equal to 14. Okay, I want to go back to this part because here I said that here mean is x bar is 90.9, and also I want to find out what the answer is for these two. Okay, let's finish this. So that is equal to, here that part is given, population mean is 100. Here is population mean, which is equal to mean for our x bar, it's equal to 100. And here on this part, standard deviation for sampling distribution here is on top. I have is that, see here standard deviation for your population is 15, and our sample size is equal to 9 based on what we have here on top. We have for each row we have 9. That's why sample size is 9, so square root of 9. So the answer is 15 divided by square root of 9 is 3, so here is 5. And but here on top you can see that this was given. This was population mean was 100 and the standard deviation of the sample mean is 4.88. So a standard deviation of sample mean 4.48, 4.88. This was given, and here we got 5. This is close to 4.88. Okay, now go back to second page, example number 1. So in this part, we need to describe the sampling distribution of x bar. Or sample mean. So this one is sample mean. Okay, exactly same as the previous page. As I said here, population and mean for that part is 80 and standard deviation is 14. So based on that, we need to describe the sampling distribution of sample mean. So this is equal to population mean, and that is equal to 80. Okay, then we have standard deviation of sample mean. That is equal to population standard deviation divided by square root of our sample sizes n. So standard deviation here is 14 divided by square root of here sample size is 49. So 14 divided by 7 is equal to 2. Okay, so adding this part, that the sampling distribution is normal. And that is because the population is normal. So in this example, this is normally distribution. So normally distributed. This was given. See, here we have normally distributed. So that part is important, and based on that, we concluded that the sampling distribution is normal since the population is normal. Okay, then part B, we need to find this area of what is given, and that part sample mean is greater than 83. So what's the answer for this part? And same thing for part C. What is the area when sample mean is less than or equal to 75.8? Okay, so here we have sample mean exactly same as previous chapter. Remember when you had X, we need to find Z first. So in this part again, first step, we need to find Z. So Z is equal to on previous chapter we had X minus mean divided by standard deviation. Here is sample mean minus mean divided by standard deviation. So this is equal to, okay, I was looking for, okay, what that mean was, let me see. Okay, so x is 83, x bar 83 minus our mean is 80, and for standard deviation here we have this part is 2. So we got 1.5. Okay, now finding the final answer. So that is equal to, so instead of x bar, now here we have z greater than 1.5. Now for this part, use table and finding the, okay, let me show that. So z is 1.5, and that is positive. Okay, so here on left column we have 1.5. Okay, so this one is 0.9332. So we're gonna use that one. Okay, let's go back to lecture. So it was 9332. So the answer for this part is 0.0668. If you remember it, since this one is greater than 1.5, what that means, this is a right tail, and when you have the right, when you need to find the right side, you need to subtract. So you should subtract 1 minus what you have on left. So this was on previous chapter. Now part C, do the same thing on this part. Since here is x bar, first step, find z. So this one's equal to, for x bar we have 75.8 minus mean is 80, and standard deviation we have 2. So this is from this part. And that is equal to negative 2.10. Okay, now finding the answer. So x bar less than or equal to 75.8 is equal to probability of z less than negative 2.10. So here we have less than, so this is on left side. Okay, let's go back to table. we have negative z. Okay, so negative 210. So negative 2.1, and here is 0. We have, adding these two, we have negative 210. So what that means here in the body of the table, the answer is 0.0179. So the answer is 0.0179. Now part D, what is the area when export is between 78.3 and 85.1? Okay, so again, instead of export, we need to find Z. So probability of exactly same as the part D, B and C. Now Z is between negative 0.85 and here we have 2.55. Okay, so what we have here, if you remember, between Z is 0, and here is negative 0.85. And here we have 2.55. So we want to find the area between these two. So that is equal to, so using table, find area when Z is equal to negative 0.85 and here Z equal to 2.55. Okay, so first negative 0.85. So here is 0.8 and here on top we have 5%. Adding these two we have negative 0.85. So the area is 0.1977. Okay. And the other one for when Z is equal to 2.55, that is positive. So 2.50, here is plus that part, we have 2.55. And the area is 0.9946. Okay, so probability of Z is between, for negative 1 we got, for this number, negative 0.85 we got 0.1977. And here for when z is equal to 2.55, we have 0.9946. So that is equal to 0.9946 minus 0.1977. So the final answer is 0.7969. Okay, now this part is approximately normally distributed, and mean is 266 days, and standard deviation is 16 days. And we don't have sample size on this part. So no sample size given. What is the probability normally selected pregnancy last less than 260 days? So probability of when x is less than, because here we have less than, and it's 260. We use this one. We're not using this part. I'm not using x bar because here we don't have sample size. Okay, so based on what we have here, this is equal to, again, since we have x, first find z, and z is less than negative 0.38. Remember, z was x minus mean divided by standard deviation. So x is 260 minus mean 266 and standard deviation 16. So that is equal to negative 0.38. Okay, here on this part I actually rounded this. So I rounded this part to two decimal places. Okay, so then finding the answer for that part. So after that, we have this part. Using table, finding z equal to negative 0.38. Okay, negative 0.38. 8 here is on top. So the area is 0.3520. Then part B, suppose a random sample of 20. So here sample is 20. And we need to describe the sampling distribution of the sample mean length of human pregnancies. Okay. So mean is equal to population mean, and that is equal to, okay, based on what we had here on top. Okay, here we have mean, population mean is 266, and here we have sample size. So what that means, we can have this mean for export equal to population mean, and that is equal to 266. Now standard deviation is equal to population standard deviation divided by square root of sample size. So from here we have 16 divided by sample size is 20. Using calculator running this, the answer is 3.578. On this part again, this is normal, and that is because population is normal. Now part C, what is the probability that random sample of 20 is a mean period of 260 or less? Here again, this is sample size 20. So in this part, we're gonna use X bar because here we have sample size, and that is less than 260. So again, finding Z first. So X bar is 260 minus or minus 266 divided by 16 divided by square root of sample size is 20. And that is equal to negative 1.68. So finding probability of when Z is less than negative 1.68 using table, here is 0.0465. Okay, I didn't ask us to interpret this one, but let's interpret based on what we got here. About 46.5, and that based on 1000. So out of 1000 samples of size equal to 20. They have mean less than 260 days. Okay, then part D, what is the probability that random sample of 50 now? Here, n is 50. And again, has a mean period of 260 or less. So exactly same thing. The only difference here, sample size is 50 instead of 20. So first step, convert alpha into z. So z is equal to, I'm writing this again here, so x bar minus. So when you have x bar, you want to use the c. So 216 minus 266 divided by 16 over square root of, here, this is n. And that is equal to negative 2.65. So using this part here on top, z less than negative 2.65. Using table, so let's go back to table. So z is negative 2.65. Negative 2.6, and here is 5. The area is this one, 0.0040. What might you conclude if a random sample of 50 resulted in a mean period of 260 days or less? Okay, so this was from previous part D, and we got 0.0040. So since part D, For the upper, we got 0.0040. And since this 0.0040 is less than 0.05, this is unusual. Therefore, our conclusion is that the sample likely came from a population whose mean period is less than 266 days. Okay. So population, so that came from the population where mean was, for this population, mean was 266. Okay, then part F, what is the probability a random sample of size 15 will have a mean period within 10 days of the mean? Okay, so what's important on this part is that here is within 10 days. And sample size is 15. So our mean is again 266. Now finding the standard deviation based on sample size, which is equal to 15. So population standard deviation was equal to 16 divided by square root of n is 15. Okay, so that is equal to 4.1312. Okay, now we need to find the probability. So the probability when x bar is between. Okay, so here we have the point is that here we have within 10 days of mean. What that means, so mean is 266. So 266. So on this side, I want to add 266 plus 10 to have 276. On this side, 266 minus 10. So here is 256. So I'm using 256 and 276. So that is equal to, since here is x bar, instead we need to find z. So z is between negative 2.42 and here is 2.42. Using table, find the answer for when z is equal to negative 2.42 and also z equal to positive 2.42. Okay, so first negative 2.42. Here we have 0.0078. And the other one is positive 2.42. So area is 0.9922. So probability is between 0.0078 and here is 0.9922. So finding what we have in between is 0.9922 minus 0.0078. And that is equal to 0.9844. So I'm gonna draw what that is. Once again, that where we have z equal to 0. Here on the side, z is negative 2.42. And here z equal to positive 2.42. And we got the answer for this part, what the area is. So for this part, area was 0.9844. Okay, so we finished that part. Now in this part we have the central limit theorem. So regardless of the shape of population, the sampling distribution of X bar becomes like approximately normal as the sample size n increases. So if sample size n increases, the sampling distribution of X bar will be normal. Okay, so I wanna add something here on this part. So to be normal, one, we should have the original population normal. And also sample size should be greater than equal to 30. Okay, we have that for here. So I think here I have typo. Let me see. Oh no. No, that's fine. Okay, so if the distribution of population is unknown or is not normal, then the distribution of sample mean is approximately normal, provided that sample size is greater than or equal to 3. So we're going to use that later. And the next example, we have shape of distribution of the time required to get an oil change at the 10-minute oil change facility is unknown. However, records indicate that the mean time for an oil change is 11.4 minutes. So mean, here we have 11.4, and standard deviation is 3.2. So here is mean, here is standard deviation. Part A, to compute probabilities regarding the sample mean using the normal model, what sample size would be required? See, on this part, a sample size is not given. So based on what I said on previous part, here since we don't have that sample size was not given, if we want to have that part normal, we should have sample size greater than or equal to 30. So without knowing the shape of the distribution, you need to have the sample size greater than or equal to 30. Okay, now part B, what is the probability that a random sample of n equal to 40, so sample size is 40, resulting in sample mean a time of less than 10 minutes. Okay. So finding the probability when this x-bar is less than 10. So sample mean is less than 10. So this part we have normal distribution, and here mean is equal to, okay, this was on top, is equal to 11.4. And standard deviation is equal to, okay, here population standard deviation is 3.2. Square root of sample size is 40. So here is 0.5060. Okay, so again, to find the answer for this part, we need to find z. So z was x bar minus divided by so x bar 10 minus mean 11.4 divided by 0.5060. So here is negative point, okay, negative 2.77. So now here we have z less than negative 2.77. Using table, the answer is 0.0028. Okay, so here z was negative 2.77. And the area for this part, area probability or proportion was 0.0028. Okay, now part C. Part C, suppose the manager agrees to pay each employee $50 bonus, and if they meet a certain goal, a typical salary oil change facility will perform 40 oil changes between 10 a.m. and 12 p.m., treating this as a random sample. So this is a random sample. What mean oil change time would there be 10% chance of being at or below? Okay, so we have 10%. Okay, so sample size is 40. Here again, based on what we had on the previous part, this is equal to 11.4. And standard deviation, (3.2) divided by square root of 40. So it's 0.5060. Okay, now finding the probability when sample mean is less than, I don't know what we have here, and that is equal to, so equal to 10%. So what mean or change time would there be? So this one is time. So would there be 10% chance of being at or below? Okay. So here, probability is equal to 10%. And we need to find what we have on the output. Okay, using table. Since z is, okay, let me go back here. Since we have, we should have z on this part. As I said, here z is here on this part, z is 0. On the right side we have positive, and on the left side we should have negative numbers. So based on this part z for negative numbers, in the body of the table find 0.10, or the number that is the closest one to 10%. Okay, I think, yeah, this one is the closest one. See what we have for z is negative 1.2 going on top. Here is plus 8%, so we have negative 1.28. That is z. And here, this one was probability. So z is equal to negative 1.28. When area is area, probability, or proportion is 10%. Okay. Okay, now I want to find what we have here on this board. So z is equal to x bar minus mean divided by standard deviation. So z is negative 1.28. I should find this x bar minus mean from this part is 11.4. and standard deviation is, here is 0.5060. Use cross product, negative 1.28 times 0.5060 equal to x bar minus 11.4. So on this side we have negative point. So negative 0.64768 equal to x bar minus 11.4. So add 11.4. So x bar is equal to 10.8. So since that one was time, this means we have 10.8 minutes. Okay, so this was section 1. And then later we'll start section 2 from this chapter. Okay, bye-bye.